Professor Sam's laboratory, the pushy difference. Welcome to Professor Sam's rheology lab. Dr. Sam, a professor of material science, was bursting with a demonstration. Flux, he announced to his robotic lab assistant. Today, we will explore the pushy difference, the resistance to shear stress between solids and liquids. Flux made an excited little burst sound, adjusting his optical sensors. Dr. Sam pointed to a big, bright blue block of viscoelastic super squish clay sitting on the table. This, my assistant, is our reference solid. Solids possess a high yield strength, meaning they resist a change in shape. But a little force can make a lasting difference. Dr. Sam put the clay block on the table and pressed down hard with the palm of his hand, squishing it flat on one side. Dr. Sam lifted his hand. See, the solid deformed, and importantly, it will retain this new squished shape even after the load is removed. Flux poked the new flat side carefully with a little robotic finger. Now for the tricky part and a fluid dynamics portion, Dr. Sam said, reaching for a big glass beaker full of shimmering neon green non-Newtonian slime gel. This is our test liquid. Dr. Sam picked up a huge, sturdy mixing paddle. Watch what happens when I apply a continuous tangential force, or what we call shear stress, a very fancy word for a persistent side push. Dr. Sam began to stir the slime gel faster and faster. The green liquid spun into a crazy, beautiful vortex, never locking into a shape. It just kept flowing and yielding. The fascinating thing is this: as long as the shear stress is present, the liquid keeps changing. It never stabilizes in a new geometry. Dr. Sam explained, passing to look at flux. The solid resisted, changed its form once, and that was that. The liquid, however, continuously yields to the flow. It flows and flows and flows, Dr. Sam concluded, setting the mixing paddle aside. So, flux, a solid undergoes elastic or plastic deformation and stops. A liquid exhibits continuous deformation. It flows as long as a force is applied. Rheology is both squishy and swirly.